Mr. Hissner here, and today we're going to continue with triangle congruencies. Now this is our fourth way to prove that two triangles are congruent, that the two triangles are the same triangles. And today we're going to look at what is called angle side. So here we have some angle sides. Now just like before, here is our two triangles, angle 1, angle 2, or side 1. Now notice, I'm not skipping around. Here's a side, here is a angle, right? So here's a side, here's an angle. Notice that if I went counterclockwise, if I went around this way, I would have to skip a side and skip an angle. You can never skip two things. You can't skip a side and an angle. You can skip one thing. So here I'm going from an angle, skipping a side, going to an angle, going right to a side. So you can skip one thing. You can't skip two things. If you skip two things, you've skipped too many things. You've skipped too many things. That is a pun. Okay, so let's look at our congruency here. So our congruency here is, well, our angle is angle A is congruent to angle D. We have angle B, and that is congruent to angle E. And then finally we have our segments. So segment BC is congruent to segment EF. And this is this is triangle ABC is congruent to triangle DEF. And so this is a conditional statement. It says that if all of this is true in this order, if angle A is congruent to angle A, angle B is congruent to angle E, if these two segments are congruent, then these two triangles are congruent by angle side. Let's look at a proof. Nothing filled in. So let's look. I'm just going to fill in what we are given because we are given two pieces of information here. So let's just write this in. YZ bisects angle WYX. So YZ is bisecting this angle here. I'm just going to kind of mark my figure here. And then we have YWZ. So in here is congruent to YWX in here. Okay, so YWZ congruent to angle YXZ. All right, let's have a discussion. So we have a bisector. We have an angle bisector. So what does an angle bisector do? Well, it cuts the angle in half. And so that means that the angle to the left and the angle to the right of the bisector must be the same. So here we have that we have angle WYZ is going to be congruent to angle XYZ. This is an angle. Because that's what the bisector does. The bisector is cutting the angle directly in half. It's just chopping it into two even pieces, so the angles on either side of that bisector will then be congruent. And so really, this proof is basically done because we have a shared side. We have a shared side. So notice our bisector here is actually the shared side. And so what do we have here? Well, that means that this side is either going to be reflexive or, let's see, this is triangle WYZ, and this is triangle XYZ. YZ, yep, so this will be reflexive. So YZ will be congruent to YZ. And so, yeah, this is going to be reflexive. And so here we have angle side. So let's just go ahead and wrap this proof up. So here we go. Both of these things were given to us. So given. So we have our given information. And what did we say in our discussion? Well, the bisector made these two angles congruent because that's what a bisector does. So angle WYZ is congruent to angle XYZ. That is what a bisector does. That is the definition of an angle bisector. The definition of an angle bisector, it cuts angles in half. It makes them congruent. So whenever we do see a bisector, we have to look for those angles that are cut in half, that are congruent. And then finally, we have a shared side. And so we have WZ, or YZ, is going to be congruent to YZ. This is the shared side. And this is the reflexive property. And now we have angle side. So we have our one triangle, WYZ. Again, the prove is always going to be what we do last. WYZ is congruent to triangle X, Y, Z, and this is because of an angle-angle side proof.